right, so let's do the Christian. Okay, can't take that back, right? Okay, 3, 2, 1, enter. -3, -3, -3, -3, -3. That seems to be the overwhelming answer there. I'm just going to do it on this little pad here that I have. So f of x, can you remember, even for next year, f of x can be replaced with just y, okay? It's your dependent variable. So sometimes there's just a y there. This isn't function notation, okay? If you want this as an like if you just want it as a two variable, you would write it like this. That's in two variable notations, okay? This is function notation. So you should be able to work with both, no problem, right? Either one. They are giving me y, or in this case f of x, right? So this is -11 is equal to 3x minus 2. Now, I want you to show your work in these types of questions, right? What happens from one line to the other? Don't rush, okay? Do not rush. There's no point in rushing. So I'm going to keep the x here, and I'm just going to bring the 2 over, and when that term comes over, it changes sign, so it's plus 2. So -11 plus 2 is equal to 3x. This adds up to -9. This is equal to 3x. Divide both sides by 3, and x is equal to -3 because of this. Okay, don't forget your negatives, guys. Double negatives turns into a positive, right? And if it's not, then it just comes with you. Another big one, this is a complete aside, right? Oftentimes I have, you're so close, right? 3x minus 10, let's say, right? And then you're supposed to divide everything by 2 when you're isolating. So you have a lot of the 2x minus 10, right? Like you forget to divide here. And another problem is a lot of students forget to divide. Like if this had been a negative here, let's say all of this is negative. If you divide these, you technically get a +5, right? Here, you get a -3/2 because it's positive divided by negative, but here is two negatives dividing, so it should be a positive, right? So keep that in mind. Lewis, if you just joined, we're just doing some review questions here, okay? Next up, some trig. It says, write the trig ratio you would use to find length AB in the triangle. Okay. So I won't say much more. Just write in, is it sine, is it cosine, or is it tangent? Which one would you use in this case? This is my angle. That's the reference angle. So based on that, this is the opposite side. Don't know, don't care, because they want AB. This is my side that I care about, which is the adjacent. This is the hypotenuse I don't care about. So O and A, you're right, that's tangent. Tangent is the winner, okay? So it's nice, easy so far, right? Factor, we don't like to factor just yet. So here I'm getting into a bit of trouble. How about I just do this? We'll just do one question at a time. So we're basing our answer on this graph here. And this is a bit of a problem, right? With set notation, we don't have greater than or equal to, we don't have that symbol, okay? So this is what I want you to do. We're going to state the domain of this function, right? Of this relation. We don't know if it's a function just yet. Of this relation in set notation. And so this is what you're going to do. Pay close attention, okay? If you want to say, if you want to refer to this symbol right here, right? You will type less than like this. Okay, so let's say you have a domain where it's less than or equal to -3, and then if it's domain, obviously you would use x, right? And x is less than or equal to, let's say, 7. These brackets you have on your keyboards, you should. And so if you want to refer to greater than or equal to, you just use greater than or equal to. You just type it in that order on your keyboards. Okay, so this one is going to be a little trickier. So right now, try to figure out, maybe do it on paper first. What would be the domain? Oh, I should say infinity. Do we have an infinity symbol? We do not have infinity, so I'm going to allow you to do this. For infinity, just type, if you want to refer to infinity, just go, if it's positive infinity, just say infinity like this. If it's negative infinity, we're just going to use negative infinity like that. Okay? So infinity is just use INF for that because you're going to need it. All right? So go ahead and try that. Just eight the various cases you can have. Okay? When it comes to set notation, let me just talk about this for a bit, right? If you have a graph that is just, well, if it's just a line segment, so let's say it starts here and it goes to there. It could be open or it could be a solid dot, it doesn't matter. If it's set notation for domain, right, you're gonna have something like this. Or something like this. It could be that, right, this value here is not included if it's open. It could be that the top, this one is not included if it's open, so then you just don't have the equal sign, okay? That's a segment, so it has a beginning and an end. If you have an arrowhead on either end, okay, so let's say it's solid here, but then it goes like that, okay? That right there will change things in terms of set notation. When it comes to domain, it's going to be x. In this case, x is going to be greater than or equal to a certain number. Okay, and then you squiggly bracket like this. We also know that in this case, y is going to be greater than or equal to a number. Like that. So no infinity, no negative infinity or positive infinity when it's set notation. Because next year, if you take pre-cal, it's going to be marked wrong. Okay. You're not allowed to have infinity symbols in there, period. Okay, and so keep that in mind with set notation. That is the case. Even, sorry, I should have done the second one y here, right? Just to show you domain and range. So don't focus so much on the x and the y. Just focus on, oh, if it's a segment, then it will have the variable will be surrounded by numbers. It could be included or not included. If it has an arrowhead on one end but not on the other, it'll just be either x is greater than or x is less than. It could be greater than or equal to, less than or equal to, but there will just be a variable and a number. That's it. Okay. And then of course this is not including the when you have arrowheads on both sides. Okay. Then maybe I'll do that here. And this is just set notation right now. If you have arrowheads on both sides, so let's say it's one of these, like that, then x is part of the real numbers and y is part of the real numbers because it's the whole line. All x values, all y values are included. Okay. If you have a parabola like this, okay, here it's a little bit different. X is part of the real numbers. Y is going to be greater than or equal to whatever that value is, right? in this case. It could be less than or equal to if it's pointing down. Okay, so keep that in mind. Go back to your notes. I did a lot of this in chapter 5. Okay, so what do we have here? For this particular line, x is here. This is the highest, and it will be less than, right? The x values are less than 5. So it's less than for sure, and it's equal to because there's a solid dot there. So this is the correct answer to that one. Okay. Now, it's not on this question, but what about this? So this is set. What about interval notation? What if we had to give the domain an interval notation? What would it be in that case? So think about it, type it. If you had to do this in interval notation, how would you do that? I already told you which symbols to use, right? Interval notation, think about it. Might take a little bit. Let's see here. Interval. It's definitely, when you go to the left, you always have to go lowest and then highest, okay? Always lower. So negative infinity, if you look at your x values, right, you kind of project this line onto your x-axis, right? And so negative, it's going to negative infinity. So negative infinity all the way to 5 included. So 5 is included, and infinity you, of course, cannot include. It has to be in this order. Negative infinity is a lot smaller, right? Because you're going as far to the left as you can possibly get. And 5 is the highest value here. Okay? So interval should be negative infinity to 5 inclusive. Okay? So very important there. 9. Let's find the range of this function or of this relation. Okay? And let's do set first. Okay? So everybody, so here we have set. That's done. Now the interval notation. 13, figure out what's the slope of the line perpendicular to that equation right there. What is the slope of a line that would be perpendicular to this one right here? It would meet it at a 90 degree wherever they do touch. This is going to take you a little longer. Go ahead and figure it out. Get some scrap piece of paper and figure out what would be a slope that would be perpendicular to this line. They're not being specific. They're not saying and goes through this point. It just has to be perpendicular to this line. Figure it out. Sorry, my printer is going. The slope that's perpendicular to this one. So first of all, figure out the slope here. -3, divide both sides by -3. That gives you y is equal to -6 divided by -3 is 2x, and this would be -1/3. The slope here is 2/1. Okay? That is the slope of this equation right here that you're presented with. A slope that would be perpendicular to this is the negative. It's the negative of that for sure, which if you think about it, this is positive, so you know that this will be negative. Reciprocal, which is the you flipping that, right? So this is the slope that would result in a line that's perpendicular to that one. Okay? So I think the 1/6 folks, you were probably just focusing on this, right? And yes, if that's the case, but y wasn't isolated, so you don't really know your slope just yet. Okay? But hey, this is I actually, if I got 100% all my answers 100% correctly, then I'd be like, wait a minute, right? Are you guys cheating? But it happens, right? It happens. We all make mistakes. Don't even worry about it, okay? Let's continue. Write an equation of a line with a slope of 0. What would that be? This should be pretty easy to do. So I'll give you just a couple seconds to type it in. An equation with a slope that has a zero slope, what would that be? It could be anything, but it looks a certain way. All right, 5, 4, 3, 2, 1, and go. What would it be? The equation of a line with a slope of 0. Everybody likes 2 for some reason. Y is equal to 4, yeah. Y is equal to 1. Y is equal to negative 1,354. Nobody's going for those numbers, but that's okay. All right, that's correct. If you see the chat, that's correct. Anything, it's basically in general, y is equal to a number. That's it. I mean, you would need to give me a number, which all of you are doing. Great. So that is correct. What's a vertical line? A vertical line. So this line would be a horizontal line going through that number, right? So if this is your x and y axis, it would be going through that number right there. A vertical line is x is equal to a number, and it would be going through that x value. It could be negative or positive. Okay, so remember that. Your vertical lines or horizontal lines. Remember your intercepts. How do you find the intercepts, right? So you got to go and look that up. 15. Thank you for participating, folks. I really would like you, even if you're not typing in your answers, I still want you to try it at home on paper, okay? I might be going a little faster, but that's fine as long as you're trying, okay? 15. So write the slope point form of the equation of the line that passes through here and is parallel to negative 2x plus 3. So go ahead and do that right now. Extend this a little bit, okay, because a common mistake will arise here when rewriting it. So we know that the slope of this equation is negative 2 because y is isolated. So watch out for that. If it's not, you would have to do some extra work. Okay, so the slope of the first line would be negative 2. A slope of the second one that would be parallel would then also be negative 2, right? Because if they have the same slope, we know they're parallel. So here we go. If we write it in slope point form, we know that it's y minus y1 is equal to slope x minus x1, right? And so we have y minus y1, which is negative 3, so it turns into a positive. And then we have negative 2, x minus 4, because 4 is positive. If you plug it in here, it goes like this. Okay, so that'll be it. If you got that, you know, pat on the back. Okay. If you want to rewrite this into slope intercept, because that's, you got to understand the slope point is actually my favorite formula, because if you know a point and a slope, you can just use it, and you can either even graph it just by looking at it, right? This is my starting point, which is 4, negative 3, and then I use my slope to find another point from there. I don't need the y-intercept to get me started. It has a point in it. It's just not on the y-axis. A lot of us prefer that, and that's probably because we start with that form, and then so you're stuck. You're kind of like saying that's how it has to be all the time. You don't need to rewrite this to graph it, okay, folks? I would actually say it's probably best not to, because if you do make a mistake in rewriting, then your graph will be off as well, okay? So could you rewrite this? Absolutely, right? I would have liked to extend this like this. For example, what if they asked for a slope or a line that would be perpendicular to the one you started with? That would be negative reciprocal of this, or right, of this here, sorry. So negative of a negative is positive, so it's just 1/2 like that. So pay attention, just watch me maybe for this one, because I want to address this issue that comes up again and again. So the other part would be the same, right? Y plus 3 is equal to 1/2 x minus 4. So this is going to be a line perpendicular to the one we started with, this one up here. How do we know that? Because we have a negative reciprocal of that slope. Okay? So we know they would collide at a 90. If I asked you to rewrite this either general form or y-intercept form, that's when the problem arises quite often, okay? So watch what I'm going to do here. I'm going to break this down into two. If I were to go general, let's say I asked you to do that in general form. So then I would go y plus 3 is equal to 1/2 x minus 4. You want to get rid of that denominator. So you go times 2 here. And watch this. On the other side, please put the brackets around this because you're multiplying both sides by 2. And I too often see folks multiplying just by the first one and not by the second one. And then everything else is off, even though the work was pretty good. So 2y, and watch your signs, right? Plus 6. In this case, it's all positive, so no big deal. This 2 goes with that. And this happens to be a 1. Watch for -1 or -2 or whatever. Because it's 1, I don't need to really worry about distributing. In general form, you want everything over on this side. So x comes over negative. The 2y is already there. The 6 is already there. The -4, I'm going to bring it over, adding. And so that's equal to 0. That's -x plus 2y plus 10 is equal to 0. Here I need to multiply the whole thing by -1 because I don't want fractions and I don't want a negative a, right? Remember, this is a, this is b, and this is c. Okay, so a is negative, so we want that positive. So there's your general form. I will do a little cheat. I will, from here, go to y-intercept. Because the first step I need to do regardless for which form I'm stating my answer in. I'm just going to take this, and this case, 2y is equal to x minus 4. The 6 comes over subtracting. So it's 2y is equal to x minus 10. Divide everything by 2. Y is equal to 1/2 x minus 5. So both forms side by side, all from the slope point form, and both of these would be perpendicular to the one I started with. And the reason I did that is because I wanted to have a fraction as my slope, and then show you how this is the biggest, this is my area of concern right here. You distributing, and on top of that, signs. You got to watch out for signs, okay? Sorry about that rant. Okay, next. 16, write it in general form. So go ahead and do that right now. Shouldn't take you too long, but how would you get that in general form as you see it, okay? So let's take 2 minutes here. And, okay, so where's my pad here? To get that in general form, I need a, b, and c to be integers, and I need a to be positive, okay? So -x over 2 plus 6y is equal to 8. A bunch of things that need to happen, right? I also need an equal to 0 on top of everything else, okay? So what can I do first? Listen carefully. Don't just fixate on this example. Imagine, right? Let's zoom out. It could have been that all of these had a denominator other than 1. It could have been that you had like a 2, a 3, right, and an 8 or something like that. you gotta pick the LCM, the lowest common multiple of all of those denominators. So if you had 2, 4, and 8, then 8 is your lowest common multiple because 2 fits into 8, 4 fits into 8, and 8 obviously fits into 8. So then you would multiply the whole thing by 8 to get rid of all fractions. All right. So that's the thing that I want you to think of here. In this case, it's 2 and a is negative. So watch what I'm going to do here. I'm going to take this whole thing and multiply it by negative 2. Whoa, 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 what happened? You could have first multiplied by 2, do your thing, and then you still would have ended up with a negative a value, right? So you would have had to multiply everything by negative 1 as well. So in this, you do 2 and 1. So this gives you x, right? 6 times negative 2 is negative 12y, is equal to, don't forget that, 8 times negative 2 is negative 16. So then it's x minus 12y. The 16 comes over, so I have to say those that put plus 16, you got it right. Okay, that is your final answer there. Okay, so pay close attention to what I've done there. You may have done it differently. I'm not too picky on it has to be done exactly the way I do it, but I do want to see how you got there. Not just all of a sudden things pop up out of nowhere. It's like, what did you do to get there? Okay, that's what I'm really interested in. Okay, all right. And here it is. Write that equation as an equivalent equation without fractions. So basically saying rewrite this thing without fractions. How would you do that? Let's go one further. I will just say rewrite that. This is way easier. I don't know why. Let's get rid of that. Write this in general form. Then I'm covering all my bases because general form does not want fractions and it wants everything on one side. Okay, so go ahead and do that. This is what I just talked about a little while ago, seconds ago. So go ahead and try that. Let's see if we can ace this one. Okay, let's see how we do on this one. The LCM of the denominators would be, in this case, 3 and 5, that's 15, right? So I'm going to go 2/3 x minus 1/5 y is equal to 1. Multiply the whole thing. This goes back to solving systems, remember? You want to get rid of denominators. So that might be the first step before you even do anything else. Before you try to solve by elimination or substitution, you first get rid of your fractions, right? That's like the first step. So you might have to multiply again when it's solving a system. So multiply that by 15. I don't need to do negative because I want this to be positive, so I'm just going to leave it at that. So here you just have to maybe, right, 2 times 15 is 30, divided by 3 is 10x, right? 1 times 15 is 15, divided by 5 is 3, but you have your negative there, is equal to 15. And then one more step, you bring the 15 over. I feel like I kind of misled some of you with the bringing stuff over. A lot of you just like add 50 or subtract 15 on both sides, and that's fine. Like if the bringing over throws you off, even though it's a valid way of showing your work, right? If one line to the other shows me that the term came over and changed the sign, that is a valid way in math. We know that, oh yeah, that's exactly what should be happening. What you really did is subtracted 15 on both sides, right? So that is that. Okay, let's keep going. You might be able to get a few more in. 18 and 19. Okay. 18 says Write the second equation in a system. Let's do 18 only for now. Write the second equation. So just write me a second equation, okay, that would have no solution. Like if you made a system and this was the first equation and you wanted to now make it a system, right, and introduce a second equation, what would that second equation have to be? And it will vary, right, from one to the other, or from one student to the other. In this case, it will vary, but how would you know that it has no solutions just looking at it like that? So go ahead and try to figure that out. I will actually probably give you a bit of a shortcut today on doing this. Okay, we don't have a whole lot of time, so I'm just going to ask, just give it a try. Just type in something that you think would meet the criteria. See, you might actually get it right. Who knows? So write me an equation. It doesn't matter what form it is in, where you would know they have no solution. So go ahead. 3, 2, 1, enter. 2x plus 4, 2x plus 5, 2x plus 2. Okay, Lance, go big or go home, right? I like that. I like that. That would be a difficult graph to make, that's for sure. Yeah. Okay. Let's see why they came up with that. Okay. I showed you the fail-safe method is to rewrite that into slope-intercept form. Okay. So I would have said, well, negative y, right? The 2x comes over, plus 3, divide everything by negative 1, y is equal to 2x. Don't forget about this, negative 3. So this is that original equation. This would be our first equation. Our second one, we would want it to have the same slope, but this could be plus or minus anything you want other than 3. It can just not be 3. Okay? Because if that is the case, if the y-intercepts are different, so these are both pointing up, right? If this had been a negative 3, and let's say you say plus 5 for this one, then you'd be way up here, and they have the same slope. They're rising and running the same rate, so they will never meet. Okay? So yes, you are right. Let me introduce a shortcut to that. 2x minus y is equal to 3. All you have to do, because you know that it's between these two coefficients that where you get your slope from. So if you keep them untouched and just change this to whatever you want, because it's from the constant that you're going to get your y-intercept from. Not like these two here. If you keep them unchanged, when you bring everything over and change it up, it's going to still have the same slope. But if you just, in this case, were to change that, you would in fact have a different equation that has the same slope. And so these two would also be, would have no solution. Okay. How many solutions does the following system have? Just by looking at it. You should not have to rewrite this one. You should just look at it. And the answer is, because time is almost up, the answer is infinite number of solutions, because you can tell that this equation, right, to get our second one, all we did in this case, multiply it by a constant. There's a pattern, right? 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. So they're actually, we're talking about the same equation, right? Infinite number of solutions. Coinciding lines, right? Lines coincide. Okay, I'm going to wrap it up there. Strongly encourage you to open this. This is in the Cume review section under classwork. And basically start with 8 and 9 for chapters 1 and 2, because we're going to forget about all the converting. And then you skip to chapter 5, 6, and 7, which has all the stuff we talked about today. I did not talk about finding the domain and range of a discrete relation where you just have points. You actually cannot use interval notation there. You can only use set notation, and you have to actually mention all of the points separately without doubling. You cannot have doubles. And so that I didn't cover. I didn't cover nearly everything. I can't do that. I'm just trying to get your brains, you stir up that knowledge that you have, and hopefully steer you and motivate you a little bit to get going and get reviewing, right? So I have a review, right, that I gave you at the end of every chapter. If you want to try that, if you want to look at the tests, you go for that. There's a lot of not a lot, but some examples of finding the domain and range, but I gave you tons back in chapter 5. Don't worry about midpoint, right? Anything that has midpoint, don't worry about it. We scrapped it. But then back in 8 and so forth, you can do all of those, as well as solving systems as well, right? That's all there. So I will do a bit more of this tomorrow. Thank you for your time, folks.